Okay, assalamu alaikum. So we are going to continue on part 2. So here we have the non-counting loops, and these non-counting loops are basically an infinite loop. So as you can see here, this loop has no initial value, no stopping condition, no increment or decrement. So once you enter this loop, you are going to have an infinite loop which is going to run to infinity, because this is a non-counting loop. The only way to exit this loop, as we said in the previous part, is using the break statement. So here's an example of a program. So what is the output over here? In order to know the output, first of all, let us start. So we will start with I is equal to 1. I will say I is equal to 1. I will put my output screen over here. Let's go through it. I is less than or equal to 5i plus plus. So I is less than 5, yes. J is equal to 5. So my J is equal to 5. Is J greater than I? Yes, I is 1, J is 5, so C out a $sign. Okay, then see, this is the for loop. This is outside the loop. Then I'm going to increment J. So I'm going to decrement J. So J will equal to 4. Is J greater than 1? Yes. Is 4 greater than 1? Yes. Then when I'm going to display another $sign, then J is equal to 3. Is J greater than 1? Yes. Then J is equal to 2. Is J greater than 1? Yes. Then J is equal to 1. Is 1 greater than or equal to 1? Yes. Then J is equal to 0. Is 0 greater than 1? No. So I'm going to end line and start over here. Now the next one is I is equal to 2. Sorry, this is I. I is equal to 2. We incremented I. Is I less than 5? Yes. J will equal to 5 once more. J will equal to 5. Is 5 greater than I? Yes. So a $sign over here. Then J will equal to 4. Is 4 greater than 5 than 2? Yes. Then J is equal to 3. Then J is equal to 2. J is equal to 3. Then J is equal to 2. Then we have another end line, and we go for I is equal to 3. For J is equal to 5. J is equal to 4. J is equal to 3. So we are going to have $3 signs. Then we have I is equal to 2. Sorry, I is equal to 4. So then we are going to have I is equal to 4. J is equal to 5. J is equal to 4. And finally, I is equal to 5. J is equal to 5. So here we have a $2 signs and $1 sign. So our output screen will be looking something like this one over here. So if I clear it, so this is our output screen from this program. So the next is our while loop. Our while loop is quite a different loop. So if you see the while loop, we have only one expression and statements. But remember, any loop needs three things: initialization and count up and count down. So our initialization is basically somewhere around here before the while loop. Our increment and decrement is inside the statements over here. You need to put your increments and decrements within the loop. So for example, we have the bouncing ball problem, where the ball keeps bouncing half of its height every time it goes. So we will repeat until the bouncing is very low, and very low we are going to consider it as a small number over here. So every time we bounce, we go down by half. You can see this program done by while. Okay, so bounce is equal to 0. If height is greater than or equal to small bounce, divide height by 2, bounce plus plus. See, this is the increment and decrement inside the while loop. This is the while loop statement. Okay, this is the full while loop statement. Increment and decrement is here. Initialization is outside. Now, any program written in while can be done in for. Okay, any program written in while can be done in for, and vice versa. But sometimes it's good to use while statement because it's easier to read. However, you can change between them as you want. See, here is a sample run for this program. Examples of while: integer x is equal to -4. Is x less than 0? Yes. X is equal to x plus 2, so x will equal -2. Then x Is x less than 0? Yes. X is equal to x plus 2, then x will equal to 0, and you will have your C out. Here, while true means infinite. Okay, if you say while true, means your program will run infinity, and you will have this expression being executed over and over again. So this is the do loop. The do loop is a different type of expression. The do loop is a different type of expression. In the do loop, you have your expression at the end. So in the do loop, you are going to execute your program at least one time. Okay, in the do loop, we are going to execute the program at least one time. Then we are going to check the statement. So humans look at these numbers and can easily count the digits. How many digits here? We have 2. How many digits here? It's 1, 2, 3, 4, 5, 6, 7 digits. But how can a computer count the digits? So in order to count the digits, we divide by 10, and every time we divide by 10, we increment the number by 1 as long as our value is greater than 0. So for this, we are going to use the do loop, because at least we have one digit in any number. So as you can see here, we have the do loop. We increment the digits by 1. We divide by 10. Is the value not equal to 0? Yes. Then we go and do once more, and we keep on repeating the numbers for as many times as we need. And this is a sample run for this program. These are some examples for the do loop, which we can discuss later on. And here are some types of input loops where we can use them. Use infinite loops, again with a break once you want to exit your loops. And here is how to choose between for, while, and do while. For me, I prefer if you use for loop all the time. However, you need to know how to use while and do while. This is all for this section. Hope to see you all soon.